So we're going to talk about statistics in SQL Server, and this is one of my favorite topics. So I'm going to zip through some of my beginning slides here because I want to get to talking about the real content. This is all the information about me, and really the most important thing on here is my email address, erin@sqlskills.com. If you have a question that doesn't get answered today, feel free to send me an email. I'm happy to talk about statistics at any point. The SQL Skills team, I have our names up here on the screen because sometimes I talk about other members of the team and I want you to know that they're real people. So Paul and Kimberly are the owners. Tim, Jonathan, and myself are consultants in the team. We offer training at conferences. We also do our own training immersion events that are going to be online this year. And we do provide consulting as well. So if you're interested in learning more about SQL Skills, please hit our website. I've got multiple links up here, but SQLskills.com is where you want to go. And the scripts, the slides for today, they are going to be available on GitHub. And I'm just going to bring this up for a second. And actually what I should really do is take this and throw this into the chat somewhere. But I don't know how to do that. So hopefully if you just search GitHub and my name, Erin Stellato, you'll see this SQL Server Statistics repository, and you can grab everything from today there. Please enter any questions you have in the comments section. I'm not going to read the abstract. I'm hoping that you all have an idea of what we're going to talk about here with regard to statistics and their importance when we talk about them as it relates to SQL Server. So we're going to do a review, and we're going to look at how we find statistics in SQL Server. And then we'll talk about what happens when they go bad and how that can affect performance. And we will also then talk about how we update them, because that is really one of the most critical things. So the reason that we care so much about them, the reason that I have done, I don't know, well over 100, I don't know if hundreds sessions on statistics, is because they are absolutely essential when we talk about performance. And a statistic in SQL Server is information about the distribution of data in a column or a set of columns in a table or a view. So if you, let's say you have a column which is customer ID, and you want to understand not just maybe how many, it's not like how many different customer IDs we have, but customer IDs as it relates to the number of orders that we have in the orders table. Our statistics are how many customer IDs do we have for all these different orders, right? What does that look like? And it's important to have these stats, to have this information available for the optimizer, because that determines what it's going to do, what kind of plan it's going to generate. And it uses these estimates from stats to figure out how many rows are going to be returned, which is also called cardinality. So you may hear the terms cardinality estimator, right? Which is basically, we're going to use statistics to figure out how much data is going to come back. So pictorially or visually, if you want to think about how we look at this, you submit a query to SQL Server, and it then goes to the query optimizer, which uses statistics to say, what is the object? What is that we're going to access? Are we accessing a table? Are we accessing an index? Are we doing a seek or scan of that index? How are we joining to other tables? How much memory do we need? So there's a lot of information that basically comes from, or a lot of decisions that are made based upon these statistics. And then from all of that information, the optimizer puts together a plan, which then gets executed. So one of the most important things is to understand that stats are going to influence the performance of your queries. Now, when we talk about stats, there's a lot of options that are relevant here. So I want to take a moment to highlight them. The first is auto create statistics. And this option is enabled by default whenever you create a new user database. I recommend you leave it enabled. Auto update statistics is also enabled by default when you create a new database. And I recommend you also leave that enabled. There's a third option here, which is auto update statistics asynchronously. This One of my good friends, Glenn Berry, definitely recommends that you update this or that you enable this option. It is not enabled by default. And there's something I want you to understand about that before you decide if you're going to or not. So I'm going to come back to that later on. And then there's also this option of auto create incremental statistics, which is going to be relevant for you if you are using partitioning. If you're not using partitioning, don't worry about it at all. Now, these stats, how are they created? There's multiple ways that they can come into existence within SQL Server. The first is automatically. Every time you create an index, every time you create a filtered index, every time you create an indexed view, you will have a statistic created. So if you look at this syntax here, create non-clustered index on my sales orders table on the order date column. So if I create this index, what happens is when I then look at sys.stats, I also have a statistic. And notice, what's really important to notice here is that the name of the statistic is the same as the name of the index. So the index was named NCI underscore orders underscore order date. The statistic here has the same name, but they are two different entities in SQL Server. That's really important to understand. Now, we also get statistics created on individual columns within SQL Server. So if you query a column or you join on it, you get a statistic, assuming, there's a little asterisk there, assuming that it doesn't already exist because it's the leading column in an index. So for example, let me come back here for 1 second. In this example here, we created an index on order date. So if I have another query that queries on order date or joins on it, it's not going to create another statistic. There's already one here. But in the case where I have a query against that orders table where I say expected delivery date equals a value, if there's not already a column statistic there, that will go ahead and SQL Server will go ahead and create that statistic, that column level statistic for me. Now you'll notice the naming here is way different, right? The column is named expected delivery date, and we have a statistic name that starts with underscore WA underscore sys, and then a bunch of numbers and letters. That's because it's auto created and it's column level. So that's a naming convention that gets followed. So I'll take a note here that's to say, if you ever manually create statistics, don't follow that naming convention. Use your own, right? Because this is how you know it's an automatically created column level statistic. So this is the case where this column is in the predicate. When I join on the column, so here we're joining to orders based on back order ID. And here I've joined on that column. I don't have a statistic for it. And so SQL Server says, I'm going to create a statistic here on this back order ID column. So again, automatically created for indexes, filtered indexes, indexed views, automatically created on columns when we query those or we join on those. Now we can also create stats manually. So these can be created on one column, on an individual column. They can be created on multiple columns, and you can also create filtered statistics for a column. And there's a question here from Paul that says, should we ever create multi-column stats without using an index? That's a big, it depends, Paul. I would really want to talk a little bit more about the query that you're trying to troubleshoot or improve performance for before I just said yes. Because yes, there are times when you would want to create a multi-column statistic without the index. And there are other times where I would say, I really want you to create the index here. So that's a little bit bigger conversation than what's in this slide. Now, how do we look at stats once they've been created? Whether they're created automatically or whether we've created them manually. The easiest things to do is use sys.stats, and that's how we can view all stats for a table. The stats date function tells us when a statistic was updated, which can be really important when we're troubleshooting. And then my favorite thing, honestly, if I ever have to have a favorite DBCC command, it's this one. It's DBCC show statistics. And this gives us output in 3 sets. It gives us a header, it gives us a density vector, and then it gives us a histogram. And if you can understand this, and we're going to take a look at it, then it goes a long way to understanding sometimes what the optimizer is doing. We also have DMDB stats properties, and we have DMDB stats histogram. These are DMVs that were added in more recent. DMD stats properties was added in 2012. Histogram, I think that was added in 2016. We don't have a DMV specifically for the density vector, but these are easier to use programmatically compared to show statistics. I admit I grew up on show stats. That's what I tend to use. So I'm a very visual person. I like to look at what's going on in SQL Server. So we are going to switch over to a demo here so that we can take a look at how we find statistics in SQL Server. So I'm using a copy of the Wide World Importers database that I've named slightly differently. And first I want to show you two things. One is SP Help Index, and the other is the SQL Skills version of that. So SP Help Index is available by default in SQL Server. The SQL Skills version was written by Kimberly, and it just gives you a little bit more information. So I start with this because I want you to see what indexes exist, understanding that we're going to have then statistics on each of these columns. And if we look down here, we just get a little bit more information in addition to what we see above. Notably, we get included columns and the filter definition, which can be really helpful when you're doing index strategies. Now, we can also, as I said, use sys.stats, which this gives us all of the statistics that exist. So you'll see that we have 5 stats that basically mirror the indexes that we have. And then we have 3 column level statistics that exist here in this orders table. And we're really going to focus on this index, which is on customer ID. And if we look at the statistics for this, just specifically for this statistic, we are going to get this 3-part output that I mentioned. We have the header up here. And the thing about the header, and I'm going to zoom in here so that we can see this a little bit closer, is that we see when the statistic was last updated, pretty recently, we see how many rows were in the table at the time the statistic was updated. So this doesn't update continuously, right? That row count is valid as of when stats were updated. This tells us how many rows were sampled. Basically, how many rows did it go check to figure out what the distribution looked like. And we've got steps and density here. And then in the middle, we have what's called our density vector. So this helps us understand how unique the customer ID is. And then at the bottom here, we have what we call the histogram. And each of these entries under range high key, each of these are different customer IDs. And then this EQ rows says, okay, for those customer IDs, how many rows equal that? So for customer ID 1, we have 5,346 rows. For customer ID 42, we have 5,295 rows. And you'll notice there's some gaps in here, and there's only 200 steps in the histogram, plus another for a null value. But if we have more than 200 customer IDs, which we do, we can't have a step in the histogram for every one. So we end up with some gaps. And to get estimates as to how many rows are in between that, we use this average range rows. So you'll notice that we have an entry for 42, we have an entry for 45. So if we queried for 43 or for 44, it's going to use this average range rows value to estimate how many rows exist for that customer ID. So I'm going to show you this in action. And just for reference, I have the DMDB stats properties and the DMDB stats histogram DMVs there. So you can go ahead and take a look at those if you're interested. But this is our query, and we're going to enable our execution plan. And we'll go ahead and run this. And this runs pretty quickly, right? But what I want to pay attention to is how we figure out that cardinality estimate that SQL Server has, right? Where does that come from? And if we look here in this pop-up for this index seek here, which this is where we're going against that non-clustered index, and you'll see that it estimates the number of rows we're going to return is 5,295. And that matches actually how many rows it returned. So that's a really good estimate, right? And if we double check, right, it was 5,295. If we double check here back in the statistic for 42, sure enough, we see that that estimate is correct. So this is a case where what SQL Server thought was actually correct. So our statistics are accurate, they're up to date. Now, as I said, not every value can fit into the histogram. So what happens if we query for a customer ID of 52, which is not in the histogram? And so we'll look here at this plan and we'll come in and we'll see that in this case, for the value of 52, it estimates 5,404 rows. But the actual was 5,437. So it's pretty close, right? It's not too far off. I wouldn't think that that's astronomically different. And again, if we check back here and we look at our histogram and we see, okay, for 52, there's no 52, but that estimate was 5,404, right? And that's because, let me just get this all straight. 52 falls between the value of 50 and 55. And so it says, okay, on average, the number of rows for each value between 50 and 55 is 5,404. So that's where it gets that estimate. This is all well and good when we're doing literal values, right? But what happens when I use a variable? So here I'm going to declare customer ID, and then I'm going to set it to a value of 42, which we know is in the histogram, and then run this query. And now when we look at our plan and we look at our estimate, this is a little bit different than what we saw before, right? Now we have this value of 5,845.25. So I don't remember seeing any kind of decimal numbers in our histogram. And here's what happens. The value for customer ID isn't known when it does optimization, so it uses the density vector. Remember I mentioned the density vector briefly? And I said that tells how unique it is. So here's the density vector in the middle of the DBCC show statistics output. And you'll see this value is 0.001. So again, this is an estimate, or this is a calculation that it does to say, on average, how many rows return for a customer, any given customer ID. And you can do the math. So we can take that density vector and we can multiply it times the number of rows in the table. And when we do that, we can see that there's that 584.25, right? That estimate that it comes up with. So that's great, okay, if I have an equality. But what happens if I come into a less than scenario, right? So give me the information from this table, from the orders table, where my customer ID is less than some variable value that I've set. And when this one comes back, this returns tons of rows. You see it changes the plan actually. And in this case, right, estimated number of rows, we're in like 1.1 million here, right? This is way higher than the 5,000 that we were in before. And so the estimate in this case is it's taking the number of rows in the table times 30%. So it just estimates that it's going to have 30% of the rows, 1.1 million return. So now you can see that it uses the histogram to get information about how many rows it's going to return. And all we've done so far is just query with literal values. And by a literal value, well, we did a little variables here, but with a literal value, right, where we've said customer ID equals 52, customer ID equals 42. Now, maybe some of you have a lot of ad hoc queries that have literal values like this, but I'm going to guess that some of you also have stored procedures. And Alvaro says, where is that 30% coming from? That's just part of the heuristics that SQL Server uses. So you don't get to mess with that. You don't get to change it. That's the way that it is. So I'm going to guess that some of you have stored procedures. And we're going to create one here. Very simple. We're using that same query that we were just using, but we're going to put that into a procedure. So customer ID is what we're passing in, and we're going to run this exact same query before for a given customer ID. So let's go ahead and create that stored procedure. And then we're going to set statistics IO and time on. And I'm going to run this stored procedure with our value of 42. So we know this returns about 5,000 rows, right? 5,295. And if I look at my messages here, I can see that we have about 16,000 reads. And if I look at my plan, what's important here to note now is we're going to talk a little bit about the shape of the plan, what the plan looks like because of what the optimizer decided to do based on statistics. It decided to do an index seek. It said, I'm going to use that non-clustered index that we looked at before, that FK sales customer ID. I'm going to go seek that index, and I'm going to pull the customer IDs that have a value of 42. But it also needs order date, and order date isn't in this index. And so it has to go do this key lookup over here. And where we only have a few thousand rows, that's not so bad, right? It's not great. You can see I have a missing index recommendation. We're going to ignore that for now. But a key lookup for a few thousand rows isn't awful. Now let's see what happens when we do this for a value of 823. Now, you'll notice here down in the bottom right, this query returned 22,000 rows. So we just quadrupled the amount of data that we're returning. And it executed pretty quickly. But notice now that we're up to 67,000 reads. We were at 16,000. Now we're up to 67,000. We've tripled here, right? And if we look at our plan, you can see things start to look a little strange, right? The estimated number is 5,295, and the number of rows is way higher, 22,000. So what's important to remember here is that when we execute a stored procedure, the initial value that it uses to compile that is used to determine the plan, and then that plan gets cached in the procedure, right? In the procedure cache or the plan cache. So that's going to be reused regardless of what value I pass in. So if I run this same thing with the value of 422, this is going to take, it still runs pretty fast. This is, 120,000 rows are coming back. But if we look now at the messages, this is 366,000 reads that it's doing instead of 16,000 or 67,000. Right now we're up in the 300,000 range. And it still runs really fast, but this is not efficient. We still have the same plan because that's the plan that's cached. And it's going to continue to use that until something changes. And in our case, we're going to do something horrible. Something as a reminder, right? I'm just going to throw this in here just as a friendly reminder, right? Not for production. We're going to do a DBCC free proc cache, which basically means get rid of all of the plans that are in cache. So we do that, and we're going to run this procedure again, which now means that it's going to go through and it's going to create the plan based upon the estimates that it gets for the customer ID of 422. So it returns 100,000 rows. And if we look at the plan, you'll see that this is a different plan, right? Rather than that nested loop that had the index seek with the key lookup, now we get a clustered index scan. And Jan, I don't know if it's Jan or Jan, so I apologize if I don't have that correct. But yes, this is a parameter sniffing issue or parameter sensitivity. You'll hear all of that, all of those terms, parameter sniffing, parameter sensitivity, PSP. Right? So now with this value of 422, if we look at our estimates here, right, we get 119,000 rows. And it actually, that's what it returns, right? But it does a clustered index scan. And you might think, well, hang on, aren't seeks great? Isn't that what we want? Well, if we look at the amount of IO that it did, right, 35,000 versus 366,000. So this is a case where customer ID is a value that I would say is, it has a skewed distribution. Now, what do I mean by a skewed distribution? Let me show you. Let me go back to the slides and let me show you a little bit what I mean about distribution, right? If you think about the histogram, you see in the middle here, this 422, right? And there's a bunch of other values across the bottom. And we have the kind of this nice flat bit. And then we have these little spikes in there. So that is my skew, right? If I had a nice flat line all the way across for this, then that would tell me that my data is pretty evenly distributed. I wouldn't have a parameter sensitive issue. But if I look at this a slightly different way, if I order this data based by the count, 422 is all the way over there on the left side of the screen, you can see that I have a few big values and then it really evens out. So this becomes a problem in a parameterized scenario, like with the stored procedure, because the plan that gets into cache for most of these values is pretty good, but every so often it might not be so great. Okay, now how do we manage statistics? Well, you can let SQL Server do it, or you can set up scheduled jobs. And these are important. This is what I recommend. I'm going to talk about what SQL Server does, but I'm going to step onto my soapbox for a second and tell you that I really want you to manually manage statistics by creating jobs that run on a regular basis. If any of you are familiar with Ola Hallengren's maintenance scripts, Ola has a method to do this. I've written some blog posts that I have links to at the end that talk about how you can just manage stats with his scripts, not even worried about indexing, reorgs, and rebuilds, but stats alone, which I think are absolutely critical. So I could spend an hour talking just about that. But what I want you to understand is that automatic updates are going to occur even if you are manually managing stats. So you're going to make a best attempt with managing stats manually, but automatic updates are still going to occur if you have that automatic update option enabled, which you do by default. Now, again, this can be asynchronous, which means that when SQL Server detects that it needs to update stats, rather than doing it right away, it will wait until whatever query you were going to run finishes, and then it will update them. So the benefit is that whatever query you were going to run doesn't wait for stats to be updated before it executes. It just goes ahead and executes, and then stats get updated later on. The drawback here is that maybe that plan that it's going to use isn't ideal, and I want it to get stats updated and then get a better plan. So there's pros and cons to both options. Again, in your environment, you may want to try one. And if you don't notice any problems, if things seem great, then that's probably the option for you. But by default, asynchronous updates are off. Manually, again, part of your regular maintenance that you should be doing. And there's a couple options that are really useful when we talk about updating stats. One of them is no recompute, which means if the auto update kicks in, don't update stats for a particular statistic. This isn't something that you enable across the board. This is something that it's a calculated strike when you apply that to a statistic. And then there's also an option of persist sample %, which by default, when an automatic update occurs, it uses a default sample, which is about 10% or less. And if I want a statistic to always be updated, let's say with a full scan, because I have a skewed data distribution, I can choose to persist the sample % for that so that no matter when it updates, it always updates with a full scan. So these automatic updates are going to occur if I have auto update enabled when a certain number of modifications occur. And this is based on a threshold. And that threshold depends on what version and compat mode you're running. So the old threshold would be when 20% plus 500 rows had changed, 20% of the data plus 500 rows. That new threshold is the square root of 1,000 times the number of rows. So the new threshold is the default behavior in 2016 and higher if you have a compat mode of 130 or higher. In earlier versions, all the way back to 2008 R2 Service Pack 1, you can get that threshold with trace flag 2371. And what this looks like in terms of numbers is that it makes the threshold a lot smaller. Because when we talk about a table with, let's say, 100 million rows, 20% of that is 20 million rows. You could be waiting a long time for stats to update. So for as much as I want you to manage stats, there are places that don't. And so for some of those environments, those stats were getting horrifically out of date. And so this lower threshold is designed to get those stats updated on a more regular basis. So I want to show what happens when we don't update those, and also what happens with our plans. So I've got another, this is my out of date stats script. So I'm going to mess up statistics on purpose. And I did a great thing here. I had this demo where I changed my connection parameter, and it keeps going back here. So let's get this sorted out here. And while this runs, this only takes a minute or two to run. It looks like, let's see, there was another question. Are auto-created stats updated when you rebuild your indexes? It's a great question. When you rebuild an index, if I rebuild all the indexes for a table, the statistics for those indexes get updated, but the statistics for the column level statistics do not. Whether those column level stats are automatically or manually created by default. If you use Ola's script, he has an option to update all statistics, which means your index stats and your column level stats. But if you just did an alter index rebuild, it doesn't hit any column stats on a table. Great question. All right, so I've prepped this, and we're going to go back to my wide world importers B database. And we're going to just double check our statistics for this orders table. So we just restored this database. Times become really important here. 154, 3.6 million rows in the table. This sample is 171,000 rows. So this is a default sample, 10% or less, right? Not a full scan. And I'm going to turn on statistics.io. And we're going to run this query, a little bit more complicated than we were looking at before, with a few different customer ID values. So we'll go ahead and run these. Again, that 422 is in there, which we know is skewed, right? So let's go ahead and run each of these, and we'll take a look at our statistics output here. So we can see that we're getting 92,000 reads. We're getting 277,000 reads. We're getting 366,000 reads. And our durations are going up a little bit here too, right? 1.7 seconds, 1.7, 3.4. So what's going on here? Let's grab this. I have a note to myself that I want to grab that info. So I have to listen to my own directions, right, that I give myself, because I wanted it for a reason. And again, let's just double check here what we have for stats, right? Okay. So we're at 3.6 million rows, 171,000 sampled. Now we're going to, actually what I want to do here, I want to check one other thing. If 422, 823, 42. Let's look at what we have here. 42, right? Somewhere around the 5,000 range. 422, right? This is 8,000. So this is different than what we had in the table before. Okay. Now, we're going to mess with the data. We are going to add a lot of data to customer ID 422. And let me tell you, I've turned off auto update statistics. Oh, I hate it when my other demos creep in and mess up this one. So I turned off auto update statistics for this. Oh, it changed my context. Love it. And I'm going to change a significant amount of data in this table. And we're going to set all of these to a customer ID of 422. So now we've got over 500,000 rows in this table. And I'm going to run this time with the live query stats. We'll kick this off, and you can see that it's pushing this through 3 nested loops. And it's going to take several seconds for these 500,000 rows, 1.3 million rows in the end, to come through, right? I love looking at this. I'll run this again, right? So we can see, I'm going to zoom in here, right? It's estimating just a few thousand rows are going to come out here. And it ends up being hundreds of thousands. So my estimates are way off. This plan is really inefficient for the value of 422. So let's turn on auto update statistics and make sure that we're in the context of that database. And I'm going to turn off my live query stats because at this point, I'm going to make these things run a little bit faster. And now we're going to run this for customer ID 422. And this still takes a little bit of time because we're bringing back over 1 million rows, right, out of a 3 million row table. So it's not necessarily that much faster, but this is a change in the plan. Before we had 3 nested loops going on, and now we've got just this one hash match. And now we have a clustered index scan here, and our estimate in terms of how much data is going to be returned is way above that 2,600 number that we saw before. So let's look at statistics. Haley, I want to know why you're holding your breath. Here, if we look at statistics and I look at a value of 422, right, this has been updated. If I look up here, right, we were at 150 something earlier, now we're at 159. So when I turned on auto update stats, because I had modified so much data, when I ran that query, it said, oh, okay, I see that stats have changed and that I need to go, or I see that data has changed and I need to go and update stats. And after it updated stats, then it generates a new plan based on that value of 422. So I want to understand how stats affect performance now here at my procedure level. So we're going to create our stored procedure, which is just like the query we've been using, right? Now we're just putting it into a procedure, and we're going to run this 10 times. And we'll check out the plan. This plan goes back to the nested loop plan, right? So this, again, is a parameter-sensitive query. With 422, we ended up getting a hash match. With something lower than that, in this case, where it's estimating about 5,800 rows, we're getting those nested loops, okay? So 2 different plans occurring here. We've run that 10 times. And if we look at the plan cache, we can see here that this has executed 10 times. We've got 1 plan, and the query plan is what we were just looking at here with those nested loops across. Excellent. Now, and I have auto update enabled, right? Now let's just take a look here at modifications, right? So this is a pretty slick view. I like this a lot because this tells me how much churn there is, how much data changes in my table. And right here, I don't have any modifications because I just updated stats, right? And we haven't done anything. So let's go ahead and update a few 60-some thousand rows so that we cross that threshold of when an automatic update's going to kick in. And let's verify that we changed that data. We did, right? We changed about 70,000 rows. So that exceeds this 60,000 threshold with that new stats update threshold. And then we're going to run this again. And if we look at the plan, this plan looks exactly the same, right? It has the same shape that we had before. We've got these nested loops going on in here. So how do I know here if anything actually changed? Well, first of all, let's see if stats updated. They did. Remember, they last updated at 159, and now it's 202. And the rows sampled has changed. We did have a full scan before, and now we're down to just a default 171,000. How do we know that this is recompiled? This is a nice little trick here. When we look in the plan cache for this particular plan, you can see this plan generation num bumped up to 2, and our execution count reset. So even though it's the same plan, it recompiled it. So it drops the execution count, it gets rid of the info, and the plan generation num increases by a value of 1. Last scenario, we're going to recompile this procedure on purpose, and we're going to run it with a value of 414 for my customer ID. And let's see what plan we get here. We get that nested loop plan. And if we check this out, right, we can see that it's estimating 4,939 rows. So when we're down in that flat part, down on that 5,000 row range, we're getting this nested loop scenario. We're going to go ahead and modify some more data again because data changes in your system, right? Throughout the day, things change. Let's confirm that we've exceeded our thresholds for change. We have for a couple stats. New threshold is 85,000. We've exceeded it in some cases. So let's see what happens when we run with a different parameter. We switched plans, right? So enough data had changed that when I went and ran this again, it went and updated stats, and we got a different plan in here. And this happens, okay, great. We can run it a whole bunch of times, and every single time now it's running this with these values that end up returning like 5,000 rows, but it ends up doing this clustered index scan and this hash match, which is inefficient for this. Again, parameter sensitive type of scenario. And if we look here in the cache, right, we can see that this is that recompiled. And what happens here is when a plan changes for whatever reason, because a bunch of data came into the system and stats automatically updated, one of the things that folks tend to do is they tend to look at stats, which is great, but there's three things really that you got to pay attention to. You need to look to see when they were last updated. You need to understand what the sample rate was, and you also need to understand if there have been modifications. So at this point, we have a plan in cache that's a clustered index scan, which we don't love. And if we don't understand that there was a recompile, we might look at this and we might say, oh, you know what? I think we need to update stats here. I think that's what we need to do. And that's often a sledgehammer approach. And people sometimes think that it's updating stats which has fixed the issue. And in some cases it is. But some cases what happens is that updating stats causes a recompile. And the recompile means that the next time I go and execute this with this value of 414, I'm going to get a new plan. And I'm going to get a better plan and things seem to be good. But in this case, I didn't get a better plan. And this is, then people are really scratching their head and they're going, what happened here? What's wrong? Here's the thing. If you update statistics and no data has changed, right? We had row modifications of 0. Then stats are going to get updated, and they've been updated here, right? We can see that we updated with a full scan, and sure enough, that's what it did. But even though it updated stats, because no data had changed, it didn't recompile the plan. And this is an interesting thing to understand about stats, and something that I want you to think about when you're troubleshooting and looking at plans with poor performance and thinking that maybe I have a stats problem. Maybe you do. But I don't want you to assume that just because you update stats, you're always going to get a different plan. You want to look to see when stats were last updated. You want to understand what the sample rate was. And you also want to understand if you've had row modifications occur. So this is something that catches a lot of people out. And I have a note in here about it. So in SQL Server 2012 and higher, which I'm hoping a lot of you are on, right? When stats are updated, if no data's changed, the plans aren't going to be invalidated. So you won't get recompiles. Prior to that, the behavior was a little bit different. If you updated stats and you had auto update enabled, the plans were invalidated. But if you had auto update off for some reason, then the plans weren't invalidated. So understand that the estimates that you see in the plans are not always correct. I created a contrived scenario where the first case is true. Stats hadn't been updated recently. And updating stats did address our issue. Sometimes your estimates are off because of that skew, the uneven distribution of data, or because the sample rate is too low and it doesn't have a good capture of what the distribution looks like. And then you have a ton of other scenarios that can cause estimates to not be correct. But stats and looking at what SQL Server thinks is in the table and what actually is typically where you want to start. So you need to understand how to look at that histogram like we showed in the beginning. So we looked at how to do that. We looked at what happens when stats don't go so well when they're not being updated. And we talked about how to update stats. I've got a lot of references here that I'm going to kind of slowly go through while I'm looking at your questions. So if there's a question is, would the adaptive join feature mitigate what I am showing? So yes, right? That's designed to help a parameter sensitive problem, assuming that I'm going between a nested loop and a hash join, which I was in that example. So in the adaptive join scenario, which was introduced in 2017, right? You've got to have the appropriate compat mode there for that feature to be in play. 2017 was column store, 2019 supported with row store. Yes, it would flip between that based upon the number of rows coming in. Victor said, did I enable auto stats after the update? I enabled it somewhere in the middle of that demo, but initially I had it turned off so that you could see that if I'm not updating stats and I'm changing lots of data, the optimizer does not have great information. And then Rohit says, does table partitioning switching affect statistics? That's a really great question. So the challenge with statistics and partitions is that by default, unless you've got incremental on, you have one statistic, one histogram for the entire partitioned table. When you enable incremental stats, you do get stats at the partition level. The optimizer doesn't actually use them, but it does incorporate that into the overall histogram so that you don't have to go and update stats across the whole table. So to answer your question, when I partition switch, when I switch in, I want to update stats for that partition, and then those will get folded into the table partition.